Hi everyone. Today I'm going to talk about the plotting function of MATLAB. It's very important tool to illustrate your data, to show your results in a pretty way. Okay, to graph a function in MATLAB, you have two ways to do that. The first way is the numerical, and the second way is based on symbolic calculations. Let's start with the numerical one. I don't know, x can be 2, 1, 2, 0.001, 2, 2, sorry, 0 to 1. As we haven't seen this notation, but this is an easy way to create a vector, with equally spaced elements. Let's run. And as you see, we created a vector with equally sized elements from 0 to 1 with the increase rate of 0.001, as you see. I do that because I want to plot a function with respect to whole elements of the x vector. Okay, we can plot a trigonometric function, so y can be sine of x. And let's see the function values of 2 times pi times this vector. I make these scalar multiplication because now I'm going to get a vector which has boundaries from 0 to 306 degrees, but it's in radians, as you see. Okay, now let's plot x and y. This means that we are going to plot y values with respect to x. Suppress that. Okay. Yes, MATLAB draw the graph for us. Okay, let's add grids on this graph. Now we have grids on our graph. Okay, let's plot another function. Maybe it can be z cosine x, and we can plot x of z. And this is the cosine graph of from 0 to 2 pi. Okay, let's graph y with respect to z. And yes, as we know, it's the unit circle. Okay, guys, let's make some different plottings. Let's define a function which has independent variable values of x from -10 and increase with 0.01 to 10. Okay, and the functions can be y equals to 3 times x to the power of 4. Guys, I use the power symbol with a dot because I am taking the power of a series of a vector. When you are taking the power of a vector, this is the notation, a dot with the symbol, the power symbol. Okay, plus 2 times x, 3, 7 times x, of 2 is 2 times x plus 2 plus 2 times x plus 9 kg equals to times x to the power of 3 plus 9 times x plus 2. Okay, I think let's check the syntax. 3 times x to the power 3. Okay. Let's plot the graphs, the graph of y and g. Okay. But now I want to draw the graphs of these functions in the same plot. Okay. G. Okay. Let's run. Yes. Guys, this is the graph of two functions, and the red one is the y plot with respect to x, and the green one, as you see, this symbol indicates the color of the graph. So, and the green one is the graph of the g function with respect to x again. You can use grid on command again. Okay, there you see the grids. Okay, let's make another example to plot a surface. Okay. Now I'm going to use a command named mesh grid. And mesh grid creates a table with respect to x and y. These are the x values of a grid, and these are the y values. Okay, let z equals to sine of x plus cosine y. Now we have the values of x and y in a grid, but to draw the graph of this surface, you need to use surf command. Z. Here you see we have the 3D plot, 3D surfaces in a graph. And if you want to get the detailed or deeper information, as you know, you can use help surf. A little reminder. Okay. Let's add a color bar to this graph. Again. Color bar command. Yes, we add an legend a color bar here. So we have a last example to draw a counter plot. To make a counter plot, x equals to -2 times pi 0.1 to 2 pi, and y is to 0, 0, 0.01 4 times pi. Okay, x and y needs to be and again z can be sinus x plus cosine y. To make a counter plot, you need to use the command contour. I don't know the true spelling of the word. So x, y, z. Let's run. Yes, guys, this is the contour plot of the z function with respect to x and y. We have one more example, and it's about plotting vector fields. Let's start. Okay. Let's define our mesh grid, but with different syntax now. It's the same as the previous one. Mesh grid 0 to sorry 0.22. Okay, our function can be x times e to the power of minus x square minus y square. And in MATLAB, to plot a velocity field, you have a function named quiver. It is also called velocity plot. Quiver function has 4 inputs. I think when we complete this example, you will comprehend the issue. You will understand better. As you know, to obtain a vector field of a scalar function, you need to take its gradient. And we know that taking gradients or taking the derivatives in MATLAB, it's easy. We have a diff function. So let's take its gradient. I'm going to use another script to ease my job. Okay. This is our function, you know. Let's differentiate it with respect to x and with respect to y. Yes, we have the gradients now. And let's define them. Cy 3. Oh, don't forget to use dots. Okay, now we are ready to use quiver command, quiver function x, y. Let's write the gradients, arrows, dy. Okay. Here you see the vector field of the function z here. Okay, we obtained the vector field. At this point, it can be very deductive to plot our z function on this figure, this vector field. In MATLAB, it's possible to draw a new graph onto existing one. A function named hold on. Let's write hold on, and let's draw our function on it. Counter function. First the function. First variables, then our function, and we can select that how many isolines that we want to draw. Can be 10. Okay, let's run. Yes. Now you see the contours of z function and the vector field on it also. In MATLAB, there is also another way to take the gradient of a function. It's a function called gradient. So let's close this, and instead of these, let's write zx and zy equals the gradient of function z with 0.2 magnitude vectors. Okay. Now let's check the graph again. You see there is no difference between two methods by taking the gradients. Okay. I don't want to forget mention anything else. Yes, notice that we write the hold on command after the graph that we want to overdraw on, and to close this function, we need to write hold off, and that's all. See you in the next video.